Good morning and welcome. And so we have wonderful weather just in honor of the HPC User Forum. So I just want to take an opportunity to say welcome and to tell you about some of the priorities we're working on, in particular with computing at Argonne. So for computing at Argonne, it consists of 4 divisions within the sales directorate, and the sales is computing, environment, and life sciences, for which Rick Stevens is the ALD. For computing at Argonne, we have the Mathematics and Computer Science Division, MCS. We have Data Science and Learning, DSL. We have Computational Science, CPS, and also the Leadership Computing Facility, ALCF. And David Martin will tell a little bit more about ALCF. When we look at computing at Argonne, we're looking across the spectrum. And that is, we're looking at from devices in terms of sensors all the way up to HPC, cloud environments, and including the fog, where we're looking at AI at the edge, where we're bringing computing to the edge. So here at Argonne, we have, for example, projects related to the fog, looking at AI at the edge, and that's the WAGO project that's led by Pete Beckman and Charlie Catlett. And so we're looking at that with respect to different science applications, where you may have sensors in the field gathering data, but you're doing analysis on that data. So you're reducing the amount of data or the traffic that you're sending from those sensors to the HPC systems. And so you're looking at that wide range. You're also looking at your instruments as well as probably containing sensors. And so you have these complex applications for which, when we look at computing at Argonne, we're looking at computational methods, and that's looking at building models for large-scale computing. We're looking at AI, where we're looking at the learning, we're looking at the data collection, and also the curation. And then in mathematics and computing, we're also looking at building the foundational work that leads to the computing continuum, as well as looking at AI-enabled science. When we start to talk about AI for science, we're looking at multiple levels. We're looking at the applications, where we're looking at the use of AI to transform the application, looking at replacing some aspects about the applications possibly with learning, in which we're generating learning-based models based on data. We're looking also at the learning systems, and I'll talk a little bit more about the AI software and that particular level. But we're looking at delivering that learning systems to thousands of engineers and scientists with respect to their applications. We're looking at the learning systems that may be used, for example, in AI-enabled labs. When we're looking at foundational work, we're looking at the mathematics, also the computer science. We're looking at things such as uncertainty quantification. We're looking at also different aspects in terms of reinforcement learning. And then there's the hardware, where we're looking at also AI accelerators. When we start to look at the infrastructure, just to delve a little bit deeper into the infrastructure, that's where we're looking at also AI methods on the outer layer. And that's looking at the methods that we need to interface with the science, need to interface with databases, and that database includes literature. We're looking at the interface to the instruments, and that may be, for example, the hyperparameter optimization. It may be looking at surrogate models. And then if we go deeper into the layer, that's where we're looking at system software. And that system software interfaces to the underlying computing continuum. When we look at the system software, we're looking at it from both aspects. The system software that's needed to enable the AI methods, as well as the system software that's needed in terms of the underlying infrastructure. But then we're also looking at that system software to say, are there techniques in AI that can be used to enhance the system software? So it's multiple aspects in which we're looking at the infrastructure. And then, of course, we have Aurora, the first exascale, the US exascale system to be deployed in 2021. And so with Aurora, it's scheduled to deliver exaflops for HPC, and that's looking at simulations, but also exaops for AI. And that's where we're looking at 3 classes of applications, or 3 classes of computing, and that's your large-scale simulations, also your data-intensive applications, and then deep learning, and also your emerging AI for science. So with that, I'll wrap up to say thank you, but just to give you an overview of some of the things we're looking at with computing at Argonne. So again, welcome in terms of being here at Argonne to the HPC User Forum. And so.